part of my career at IBM. But it was actually after IBM that I got interested in this technology, looking at innovation. And I think blockchains, despite all the hype around them, have the potential to be quite transformative in our society. And that sort of made me want to dive into this. But as soon as I began diving in, I was sort of hit with the fact that blockchains are incredibly complex. You know, this slide here just has a few of the types of acronyms and things that are unique to this. Blockchains seem to have a language all their own. And I found that when you start, or one starts studying blockchains, you can go down a number of rabbit holes and sort of never come out. I mean, blockchains marry three completely distinct fields of distributed computing, cryptography, game theory. I mean, you could pick any one of those fields, go and get a PhD and spend your entire career in them, as many people do. And so the fact that these set of very complex technologies all come together to essentially create value, I find really compelling. And what I'd like to sort of do in the next period of time we spend is try to distill, you know, what that value is. There are people, some on the call, that mentioned that they invest in cryptocurrencies. There are others that build applications around blockchain technology. It has arrived with a great sense of promise that blockchains can solve a great deal of the world's problems. So, you know, what I'd like to do is dive in and see if I can dispel some of the myths and provide some basic education. I am not an expert in every single area of these technologies, but I think I have a pretty good sense of what's happening within the space. In addition to my work today, I am an instructor in residence at the UConn School of Business, and continue to work on this topic. But I think it's a particularly very deep topic. So, you know, let's dive in. I am sure that most of you on the phone today have heard the old adage that money equals power. And that is particularly true, but if you think about what is happening in today's society with wealth concentration, that is increasingly power that's reserved for the very few. But over the last 25 years, we have begun a complete digital transformation of society. And, you know, that is no truer than, you know, looking at the devices that you hold in your hand, your iPhones or Android phones, from which you can essentially do most of the utilitarian things in your life, from order food to watch a movie to talk to friends, trade stocks, buy cryptocurrencies, sell them, check the weather. There's, you know, the world has essentially been transformed and brought to our fingertips in very powerful ways. And we're seeing this sort of play out in the valuations of some of the world's largest companies. I would imagine most of you are familiar with a guy named Marc Andreessen. Marc was the father of the modern internet browser, and today is one of the world's fairly successful venture capitalists. And a number of years ago, Andreessen said, software is eating the world. And I just thought I would try to contrast for you why he sees that being true. What I've depicted here are the market caps of the top 5 companies in the world circa 2001, and fast forward just 19 years to today. What's
I'm
really
sorry to interrupt, but I can't really see your screen. Are you sure you're sharing it?
I can see it fine. I don't know.
You can see it?
I think I am, Doug. You're scaring me.
Professor
I can
Long,
see it too.
how are you displaying all of the people
I got,
watching.
I switched to screen share. It's working now. I'm sorry to interrupt.
Oh,
Keep
no
going.
worries.
I'm sorry.
Okay. Yeah, so what's really interesting is, if you look at the 2001 companies, these were a combination of industrial era companies and some retailers. The combined market caps of those companies was a little bit north of a trillion, $1.5 trillion. Fast forward to today, and you have 5 companies, many of them, by the way, didn't exist 20 years ago, that today are worth a combined $7 trillion out of an economy with a $23 trillion GDP. And so if you just simply sort of thought about the comment that Mark Andreessen made, perhaps he might say that it's not necessarily money that equals power, but the technology equals power. And I think we can begin to see this play out if we look at the valuations of some of the world's biggest technology companies. Think about this for a second. The world's largest taxi company owns no cars. The world's largest media company creates no content. The world's largest accommodation provider owns no hotels. And the world's largest e-commerce provider has no inventory. I don't think if we thought back 20 years ago that any of us would have seen business models evolve to the point where software is essentially controlling and creating this much economic value without the need to own necessarily the underlying assets. But what's really interesting today is that a digital currency that's 11 years old is worth $355 billion. It has no CEO, it has no bank branches, and it has no customer service department, which perhaps could lead us to believe that money equals technology. And that money, there is some great hope, would be used in a way that democratizes access to money for the many. So one of the, there are a couple of big ideas that I think will pop out of this presentation, at least I see them as sort of big ideas. And that is certainly one, that there is this hope that blockchain technology, by lowering the cost and having ubiquitous access, will make problems such as solving money access for the unbanked possible. So how did we get here? Well, in 2008, a pseudonymous inventor who goes by the name of Satoshi Nakamoto wrote a white paper, which is out on the internet, in which he or she, we still don't know who Satoshi is, wrote a paper that described a system for peer-to-peer electronic cash. He or she wasn't the first person to try to solve this problem, but Satoshi solved one of the great problems that had vexed computer scientists for probably the last 50 years. Now, when we're done, I've told Doug I would share these slides and he can forward them to you. But when you receive them, they aren't going to be the original, but they'll be a perfect digital copy and replica of what I'm presenting here tonight. And that works really well, and the internet has worked really well if we want to share information that can be easily duplicated. It doesn't work so well if what we want to share is money. And prior to Satoshi's invention of this peer-to-peer cash system called Bitcoin, the problem in sharing money was that computer scientists could not figure out how to solve what was called the double spend problem. In other words, if I sent Doug $20, there was no way for a computer system to essentially know that I hadn't also sent that same $20 to Mike. And Nakamoto, using a combination of cryptography and game theory, came up with a mechanism for the first time to allow anyone in the world, without having to have had a prior relationship with the other person. It could have been, you know, Doug's cousin on the other side of the world, that Doug could send that person $20, and this peer-to-peer electronic cash system would be able to determine that Doug had the $20, and now someone on the other side of the world has it. And the big idea here was that we could do this without any third party involved. See, some of you may say, well, Jeff, this wasn't so groundbreaking. I mean, we have Venmo. We Venmo each other money all the time. And I would say to you that's absolutely true. But think about a Venmo transaction. A Venmo transaction has at least 3 middlemen sitting in the middle of our transaction. It has, if I want to send Doug $20, we have my bank verifying that I have the $20. We have Doug's bank verifying that Doug can receive the $20. And in the middle, we have Venmo, which is owned by PayPal, validating our identities and facilitating a variety of money service features that ensure that I'm Jeff and Doug is Doug and that we can transfer that money. Now, you may say, but that works really fast and it works really fine. What's the problem? Well, the essential problem is that middlemen extract rent. You know, Wall Street and the banking and brokerage industries extract huge amounts of fees for the privilege of providing these middlemen functions. And what Nakamoto believed was, you know, why should it cost $10 to go to Western Union and send a remittance to India? What if we could simply transfer money amongst ourselves and have some ledger keep track of this with complete anonymity and the ability to verify that these ledgers are kept accurately? And so the other big idea that Nakamoto had, and I think this is, you know, playing out in the way that the world is moving, is Nakamoto also believed that one of the problems with traditional money was that central banks devalue currency. You know, we're living through a current time where the government, in order to help its citizens, is creating a lot of extra money, and the more money you create in a central bank system, the less value each dollar has. If you were to pull up a chart and look at the value of the US dollar over the last 50 years, you know, it is essentially worth a fraction of what it was. And so between countries that have hyperinflation and stable countries that manipulate their currencies, Nakamoto also saw that there could be a more perfect form of money that didn't have the ability for central banks to manipulate the value of currency, and that would be better for citizens around the world. And so in 2008, Bitcoin was born as a sort of single purpose vehicle that allowed something of value, in this case money, to be transferred between two people who didn't know each other and didn't have a pre-established relationship of trust. This slide is where I often invoke my father-in-law, who says, Jeff, what is a Bitcoin? You know, what are we actually talking about here? And when I first created it, I thought it was overly simplistic, and I've presented to a great number of senior corporate executives who've appreciated this, that Bitcoins themselves are nothing more than a string of digital characters, numbers, and letters that represent a private key or validation of your ownership of some digital asset. And that digital asset lives on something called a blockchain. So if you think of this sort of simple graphic, the railroad cars moving around the train represent Satoshi's Bitcoins, and they travel on a blockchain. And why this matters is that when this software for the Bitcoin system was developed, like much of the software world today, it was developed as an open source protocol that anybody could take and improve on without requiring any permission. And people quickly realized that you could separate the blockchain from the Bitcoins and repurpose blockchains to actually do other things. For example, transfer the value of other kinds of assets besides digital cash. And we'll talk about that a little bit, but I think, you know, the important thing for those of you that are not as familiar is that Bitcoins and blockchains are essentially different constructs. Very quickly, just to touch on how blockchains work, they represent, as you see on the right, what are called distributed ledgers. If I just quickly bounce all the way to the left and think about the IBM mainframe computer, the archetype of centralized technology, and these computers are still in use, you sort of have a central computing node that controls all the transactions and records in a system. And there are certain applications in which that, you know, makes perfect sense that it ought to be architected that way. You know, with the advent of the PC and client server computing, computing power was sort of pushed away from central nodes and distributed and decentralized, where intermediaries in the network, you know, control records and transactions, and other parties can actually maintain their own records. So you begin to have a bit of a more secure system where not all the data is stored in one place that can be attacked from a hacker's perspective or a cybersecurity perspective. If you look today, though, at the right side, with distributed computing, the idea here is that the Bitcoin network lives today on 10,000 individual computing nodes that each hold a copy of all of the transactions on the blockchain. When Bitcoin first came to be, you and I could have put a computer in our basement, turned it on, and contributed our computing power to help maintain the integrity of the Bitcoin network. In practice today, as the network's gotten bigger, companies have set up huge server farms to actually both maintain the security of the network and earn rewards. What Nakamoto came up with, this really interesting game theory idea, is that if you contribute computing power to help maintain the security of the Bitcoin network, your reward could be that you have the ability to solve certain mathematical puzzles algorithmically and earn Bitcoins as a reward. And so there was an incentive built in the system for people, you know, democratically to simply decide they want to participate in this network. But I think the key takeaway here is to understand that blockchains live in this sort of construct of distributed systems. It would also be fair to say not every computer application in the world is correct or good for a blockchain, but there are many, many that are, and we'll talk a little bit about them as we move forward. So what's so unique about blockchains? I mean, some people have said, well, aren't these things just databases? In one sense, they are, but there are some very unique characteristics that came together through the world of distributed computing and cryptography. For one, Nakamoto realized that if we're going to move money around these things, they need to be very, very highly secure. And so blockchains use a particular kind of cryptography that is incredibly secure, called elliptical curve cryptography. Most people believe, even though we don't know who Satoshi Nakamoto was, that he or she had to have been a leading researcher in the field of cryptography to actually create such a system. But we don't really know. Blockchains also are highly resilient. You know, in my prior graphic, if the mainframe computer goes down and that's where all the computing power and data is, essentially the network is down. But if there's 10,000 nodes in a Bitcoin network, as an example, and one node fails, the rest of the nodes keep working. And when that node comes back online, it receives an up-to-date copy of the blockchain and continues to participate in the network. So you have these 10,000 computer nodes located all over the world. A great many of them are behind the Great Firewall of China. But anybody can participate. They generate massive amounts of electricity and heat. There are companies that have built server farms in Iceland on ice farms, so that they don't have to pay for cooling of these rooms. But blockchains are highly resilient. They also, and I think one of the more interesting ideas about the way blockchains are built versus traditional databases is that they have this characteristic called immutability, meaning that they're highly tamper-proof. In other words, if I send Doug $20 of Bitcoin and that record is recorded on the blockchain, it would be not impossible, but it would be highly improbable, and it would be economically infeasible for somebody to go tamper with that record on the blockchain and try to change it. Essentially, somebody would have to commandeer 51% of the computing power of the entire network to change any single record, because each block in a blockchain is linked cryptographically to both the prior block and the next block to be written. So blockchains have a great number of applications where, think about this, you and I today perhaps might own a home in the United States, and we have very good copies of land deeds and land records in our county offices. There are many places in the world that don't have that, where there are great disputes over who owns what pieces of land. There are universities around the world which, perhaps unlike Fairfield and some of our universities, don't maintain records that show what degrees people have, as well as we do here, and people can't prove the provenance of their educations. You could think of a limitless number of applications where having an auditable, tamper-proof record would be a really useful application. We've just come through, I don't want to talk about it, but a very highly contentious election. There are people at Cornell and other places that are deeply studying the application of blockchain technology and its ability to be tamper-proof and highly secure for future voting systems. And while there's still a great number of problems to be solved with that technologically, I don't mean politically, there are a great number of applications in which people are thinking about the use of blockchain technology. The other thing they have is this level of integrity. If there's 10,000 nodes in the Bitcoin network, in any distributed computing network, everyone sort of has to agree of what is the source of truth, right? If you just have a mainframe and there's one record, then it's pretty easy to know what the source of truth is unless it's been tampered with. But in a distributed environment, there has to be some method of all of these computer nodes arriving at what's called consensus, that yes, this is the current version of the blockchain. And Nakamoto developed a great amount of technology and borrowed some of it, but developed technology to make sure that blockchains can reach consensus. And the last point that leads me sort of into my next slide is that they're programmable. And that sort of leads us to the second, what I would call big idea and major invention in the blockchain world. And we may not know who Satoshi Nakamoto is, but we do know who the guy in this picture is. He's a guy named Vitalik Buterin, and in 2014, Buterin looked at Bitcoin and said, Bitcoin was sort of designed for one single purpose, which was to move digital currency around a blockchain. And it would be inefficient in the world to have 1,000 different blockchains, each that only can serve a single purpose. So he developed this blockchain platform called Ethereum. Buterin, like most great entrepreneurs, was a college dropout from the University of Waterloo. And his big idea was that we could build a blockchain upon which, because they're programmable, we could build decentralized applications, which became known as dApps, and that we could add logic to those applications. So imagine this scenario that Buterin saw, that you're a farmer in New Zealand and you want to enter into an insurance contract that would pay out based on the amount of rainfall that occurs in New Zealand, whether it did or did not harm your crops. And you can go find an insurance company that would write that contract for you. But Buterin sort of saw this as a kind of simple transaction where we could memorialize that agreement into a piece of code called a smart contract. Because the blockchain can't be altered once records are written, nobody can go in and change the contract after, so it's highly memorialized and secure. And then we could just simply write the business rules into this smart contract, and at the end of the year, we could agree on some source somewhere in Google, perhaps, of a database that records exactly how much rain fell in New Zealand. And this smart contract could go out at the end of the year, query that database, determine how much rainfall there was, and simply settle that contract by sending a payment to the party that was set to receive it. And that idea has given birth to a lot of what we're going to talk about, in my remaining slides, of a programmable world in which we can memorialize business agreements and essentially perform transactions that lower the cost. I mean, imagine that insurance company, if they could develop an increasingly larger number of insurance contracts based on that technology, they could lower the cost of the back office and all the humans that they need to essentially interpret those contracts and store the paperwork for them, et cetera, et cetera. The other thing that Buterin saw here was that if all the computer nodes that participate in Ethereum sort of shared their computing and storage resources, we could actually build the world's largest computer powered by blockchain. And so today there are probably a little over 2,000, maybe around 2,300 of these distributed applications that enable a service economy for payments and finance and gaming and storage, all operating without any central party managing them. That people develop these applications, they use the Ethereum platform, and they conduct business with very minimal labor involved. I won't spend a lot of time on this. I would simply say that other than the hairdressing industry, I have not found a place today that is not experimenting at least with the idea of blockchains. There certainly today is not a killer app like there may be, for social media on an iPhone or something like that. I would say things like supply chains, improving supply chains have certainly been very popular. But every industry is experimenting with or has implemented forms of blockchain. In the finance world, there's a great deal of regulatory uncertainty about what digital assets actually are. But by my research, about $15 billion of investment capital has poured into the blockchain space since about 2015. So there is a great deal of smart money pouring into this space to try and improve things. One of the projects I did before the work I'm currently leading was for Warner Music Group. And what's really interesting is they were seeing the emergence of artists. You know, if you know anything about the music industry, artists constantly complain about the royalty payments that they get, that they're not traditionally very auditable. They have to wait a long time to get them. And so there are certain artists that Warner began to see developing blockchains to put their own music on blockchains and issue digital tokens so that they could have a direct to fan experience where the fan would use a digital token to purchase the music. The artist would receive payment immediately, in essence, almost disintermediating the record company, and be able to enjoy the music. And while these are still more experimental things than things that have reached the mass market, if you begin to sort of think about the number of places and applications where this technology could have tremendous application, you begin to see, you know, the utility of blockchains. I wanted to just touch on the next two slides because people have asked me, you know, is this the next turn of the crank of the internet and what's essentially different here? And I've sort of created these next two slides to see if I could sort of parse out what is essentially different. You know, today we can go into Starbucks, or I can pretty much go anywhere and have my iPhone automatically connect to a Wi-Fi network between my office, Starbucks, and home. It all just works quite seamlessly. But if you think back to 25 years ago when the protocol stack for the internet was being developed, things like TCP/IP and HTTP, it didn't work quite that way at that time. All of those protocols had to be developed and perfected before people could come along and build applications on top of them. And what was really interesting, you know, is that they were very highly centralized. The data in these applications is highly proprietary. But the winners of the internet economy were those companies I shared with you earlier. The companies that could make their data proprietary, like Facebook, even if it violates our privacy, as an example, value was captured in the internet at the application layer. And if you could build this sort of idea of network effects, where the concept is the first fax machine is useless, two of them are okay, but if you have 2 billion Facebook users, all of a sudden you have a very, very valuable asset. And so if you can build successful applications on top of that protocol stack, that was where all of the value is essentially captured. Now, the problem with that is it's created what we live in called these winner-take-all economies, right? I mean, there were many internet browsers, but you know, we don't have very many today. There are different social media platforms, but essentially people want to be where other people are. And so the vast majority of the value in the social media space has been captured by Facebook. Jeff Bezos figured out, you know, that convenience would win, and we don't get off our couch to buy stuff. And he's capturing the vast amount of the economic value in the e-commerce space. I sort of point out here that something really interesting, though, is that the most widely used piece of software in the world today is the Linux operating system. Linux is an operating system that shows up in every phone and every data center. It was the first open source project created by a guy named Linus Torvalds. And what was really interesting is that while Linus today has become fairly wealthy through other endeavors, he was never able to make any money off Linux itself because there was no way to invest in the protocol layer of the internet. All of the investability came from applications. But look what happens now in the blockchain world. In the blockchain world, we have what we call fat protocols. We have Bitcoin and Ethereum, and there are some others. But essentially, we have these very thin applications which ride on top of these fat protocols like Ethereum, but the data layer is very democratized. Because these are open, permissionless systems, anybody can develop applications and query the transactions that are flowing through them. These are public blockchains that you don't need permission to join. So there are very limited barriers to entry. I mean, I don't do very well writing computer code, but Doug and I could get together after this and take a version of the Bitcoin code and spin up Doug and Jeff coin. You know, now I don't know that anybody would buy it, but essentially the barriers to entry here are very, very small. And what happens is that tokens essentially create these economic incentives. And so if you have an idea for an application, in order to operate that application, you would create some sort of digital token. It creates an incentive for the developers to develop interesting software because they might make money from that token. It creates incentives for users to want to hold those tokens. It creates incentives for market makers if the protocol becomes successful to want to build financial markets for those tokens. And the value is then captured at the protocol layer. So it's not very much of a secret that Satoshi Nakamoto kept a whole bunch of Bitcoin tokens and Vitalik Buterin kept a whole bunch of Ethereum tokens, that they've captured massive amounts of economic value at the protocol layer. And it is this thesis that this idea that value is captured at the protocol layer means that the protocols will grow faster than the applications. And so you have a much more economically fair system, if you will, because of the data layer being democratized. You don't have a system in blockchain where Mark Zuckerberg owns all of your data and the privacy rights to it. So one big idea that's come out of this, and there are companies working on it, is that what if through blockchains, you and I owned our data and there were no companies that owned it? You owned the data about your educational credentials, about your medical records, about your financial history, about assets that you own. And you would decide in a very democratized way, if certain people want access to that data, what you might charge them for it. It sort of flips the sort of winner take all idea on its head. And there is some hope still to be realized, to be honest, but still forthcoming, that blockchains will offer a much more equitable society in the future, or at least they will be a building block for it. So let me sort of move towards the end here and tell you where I think this is all heading. There are a new class of tokens called security tokens that have been developed. And people now believe that it's quite possible to represent real world assets as digital tokens. So imagine, you own the Burj Khalifa in Dubai. The only way you make money from that besides selling leases is when you actually sell the building. But today you have major real estate development companies that are fractionalizing ownership of their buildings and selling portions of those assets as digital rights on a blockchain. And so if you think about this, you could do the same thing today with real estate, gold, fine art, and securities, which clearly are a topic we could spend another whole session on, but a tremendous amount of blockchain development has been aimed at disintermediating large banks and brokerages because they essentially capture so much of the fees, that if we could have a decentralized stock exchange where we could trade securities through smart contracts, we might be able to lower transaction costs and be able to keep more of the money we make from our trading. So this idea is all of a sudden you have this democratized investing where in this future model of security tokens, it doesn't matter whether you're a taxi driver, a hairdresser, or a hedge fund manager, you would have access to these tokens. And that is not really the way that the current world of investing works. There are just entire classes of assets that are only available to investors that are qualified and have certain amounts of assets. So these tokens represent not only a big change for investors, but for developers. I'm sure it would be fair to say to you here that there will be bumps in the road. Technology often outpaces regulation. I'll give you a great example. Today, the United States government classifies digital assets in 3 different ways. The Commodities Future Trading Organization considers them commodities. The IRS considers them property for tax purposes. And FinCEN considers them virtual currencies. And the SEC is still not exactly sure what to call these things. So the regulatory regime around these assets is still coming into play. So before you run out from a presentation like this and make any investments, I would urge you to sort of read the fine print. But when we talk about why this is such a big idea for blockchains, look at the size of some of these sort of parts of the market and what people see. A number of years ago when people thought of Bitcoin, which has now sort of become this store of value or digital gold, the market for it is anywhere from, 7 to $100 trillion. There are companies developing enterprise blockchains to simply save money and cost across their world. We talked about these decentralized applications where digital economies can be created, running on applications powered by blockchain. And there is an estimate that there are about $500 trillion of real world hard assets out there in the world today. And the people who sort of see where this world of securities tokens is going is they believe that regulation will fall into place and it will become further perfected to be able to define digital representations of real world assets such that they can be traded freely. So, there are some people here, and the reason you have a lot of money pouring into this space is people see these opportunities as very, very large. I want to end on one note, and then I'm happy to spend as much time as you want trying to answer any questions. The question becomes, what do central banks do? I mean, if we are developing a more perfect form of money, do central banks just sort of sit back and watch this? And I think that the answer is essentially no. In many parts of society, the payment world is undergoing significant change. I mentioned Venmo earlier in my remarks. Venmo today is now the 4th largest payment rail in the world, and it didn't exist 10 years ago. There are entire parts of the world where banknotes and coins are declining in use in society because of consumers' preference for using digital currencies or digital payment methods. So in response to this, the International Monetary Fund has been working with and creating frameworks for central banks to help them think about how central bank digital currency could play a role in their societies. China, as you may or may not know, is planning to launch its own digital currency. There are countries that are thinking of doing it as a way to avoid sanctions being implemented by major countries in the world. And the US is working on digital currencies. There are some people that think as soon as 2025, the Federal Reserve may have some form of digital currency in the United States. set forth by the government. But the country that is probably furthest down the road is Sweden. Sweden is one of my favorite countries. It's the country that gave us IKEA and the 6-hour workday. And Sweden has the krona as their currency, and they have been experimenting for a couple of years since 2016 with something called the e-krona. The e-krona is a digital currency backed by the full faith and credit of the Swedish government. And it works kind of in a way I think many of you would recognize. You would have, for example, your mobile phone, and on that mobile phone, you would have some form of digital wallet that would hold the e-krona. And if you wanted to go to use that e-krona, let's say at the Swedish version of Trader Joe's, you'd go to the store, you'd buy your items. When you got to the register, you would take out your phone, you'd look at it, it would recognize your face. And when it came time to pay, you would sort of hold that phone up to a near field communication reader that would take e-krona out of your digital wallet and pay for it. And I don't know about you, but for me that seems like it would work just absolutely fine. But there are 4,000 brave Swedes who think that just would take too damn long to do. So 4,000 Swedish citizens have gone and had elective surgery to implant digital chips in their palms so that they could simply swipe their palm over that near field reader without having to waste the time to look at their iPhone and essentially, do what I described. So let me sort of leave you with this thought that it is my belief that blockchains will fundamentally change how we exchange value in the future world. There is clearly something going on here when citizens are implanting digital chips in their bodies to be able to transact in a world that is underpinned by blockchains. Exactly where all this ends up and how fast it ends up there, your guess may be, quite frankly, as good as mine. But the advice I've given to a lot of executives and I'll leave you with is, I think this is very real. And if you want to learn more about it, I think there are ample resources to do it. If you close your office door and lock yourself in for a day, you'll find plenty to study. But I think this is a very compelling topic. And Doug, I want to thank you for giving me the opportunity to share this with your group. So let me pause there.
Right. Thank you, Jeff. I think what we'll do is we'll open the floor to questions. Does anybody have any questions for Jeff?
Yeah, Bill Calderoni here. Can you hear me, Doug?
Yeah, I can hear you just fine.
Okay. How does value get into the chain initially? That $20 that I want to send to Doug. Don't I have to go to a bank or some utility to deposit the currency before I can get it on the chain, get it to Doug, and then Doug can send it anywhere or buy anything or do anything with it he wishes on the chain? But initially there has to be some sort of intermediary.
Well, right. So the chain begins with the fiat currency, in this case, the US dollar that you have in your pocket or your bank. And there are exchanges that have been set up that allow you to convert your fiat currency into some form of cryptocurrency, could be Bitcoin or other, and store it in a digital wallet. And then you can send it to Doug. You could download a digital wallet without going to the exchange, and Doug could simply send you some Bitcoin without you having to exchange your own fiat for it. But essentially, the on-ramps to the world of cryptocurrencies and digital currencies are exchanges that are located around the world. Yes, that's correct.
But nonetheless, that entry fee, that's early in the present value of the chain. So if you're talking currency, then you're losing some fraction of the present value, for the 20 bucks to get to Doug, there has to be some additional payment to that intermediary. So there is an initial loss. The initial present value is decreased.
That's correct. If you go to, for example, the largest exchange in the world is a company here in the United States called Coinbase. They charge 3 or 4% to convert your fiat into a basket of different current digital currencies that they sell. But if Doug sent you the $20 into a digital wallet that you put on your phone, you would not pay that fee. But if you had a lot, if you wanted to invest and trade cryptocurrencies and you were going to take some amount of money to do it, you would have to go to an exchange and convert it into digital currency first. And you're correct, there would be a fee to do that.
But nonetheless, if I wanted eventually to send Doug a lot of money in order to trade on his coming bond butcher site, I'm really taking a hit, 2 or 3% up front. That's brutal.
Well, there are exchanges that charge all different fees. You could do this. I mean, keep in mind that cryptocurrencies, unlike the US stock or bond market, operate on a global basis 24/7. So there are exchanges all over the world that charge a whole range of different fees. There are places you could do it for less. Some of those are not regulated exchanges, and it may represent more risk than you want to take on. But you certainly could do it for lower fees if you wanted to.
Well, with the way bonds are, a few basis points would be a bitch. That's what I'm saying. You know, if I want to throw a few $1,000,000 onto the bond butcher, getting hit for 30 basis points is a brutal impact on the return.
Jeff, can I ask a question? This is Mike Blake.
Yep.
So, and by the way, to Bill's point, anyone who uses credit cards, the merchant's losing 2 to 3% right there off the top. So that's not that big of a hit. But I'm thinking about blockchain and monetary value. And I'm thinking worst case scenario. What if there's a war, electromagnetic pulse that fries all the computers? Does that all that value disappear if all computers are fried by some sort of, I don't know, solar flare or EMP pulse from a nuclear bomb or something? There's no paper trail, right?
Well, yes, that's a fair statement, but less so with a blockchain than with a centralized database. As an example, the 10,000 nodes that run the Bitcoin network exist all over the world. So, if one area of the world suffered from that type of event, you would have other nodes that have valid copies of the blockchain that could still essentially operate the blockchain at a reduced capacity.
Thanks.
So I did a little Googling there, Jeff, and it looks like Bitcoin is using 7 gigawatts of power, approximately equal to the power consumption of Switzerland.
Yes.
But is this really necessary? I think Ethereum is supposed to be somehow more power efficient. Isn't that right?
So Ethereum has launched a new initiative to change the way that the Ethereum blockchain arrives at consensus. What Nakamoto borrowed from the world of computer science was this concept that was known of proof of work. So that what happens is if I send Doug, just give me 1 second to describe this. If I send Doug $20, a transaction gets broadcast into the Bitcoin network. It gets picked up by the network, and now someone in the network has to validate that transaction to know that I had the $20 and Doug now has it. And so the nodes actually automatically begin trying to solve for this proof of work by running a mathematical algorithm that gets increasingly hard to solve, and that's why it burns so much electricity. And it's very electronically inefficient, even though it's highly secure. Ethereum is migrating their blockchain to something called proof of stake, where essentially a group of more wealthy owners of Ethereum will put up their Ethereum as a stake for the right to validate transactions on the network. And therefore, they won't need to run these algorithms, these brute force algorithms that burn electricity. And in the next year, Ethereum is saying that they will have migrated and become the first major blockchain to run in this new way. So, Doug, you are right that.
What do you need? You've been gone for such a long time. I'm in a seminar. I'll be right back.
You are correct that the consumption of electricity as Bitcoin and Ethereum have grown is become a problem. It's why I mentioned that about 65% of all of the computing power that maintains the Bitcoin network is in China. And the reason it is that there are places in China where they can obtain electricity at very, very low rates. And so it's not so easy to mine and Bitcoin in Fairfield County, Connecticut with Eversource because we have the highest electricity rates. But there are places like Iceland that where people can spend very little money cooling these powerful data centers, or places where the cost of electricity is very low, is where the majority of the mining activity is occurring.
Hey Jeff, I had a question about decentralized finance or DeFi coins.
Yeah.
I was wondering if you could just give a brief explanation of them, what they are, how they function.
I don't know if I can give you a simple one. Essentially, in the world of decentralized finance, you have a lot of people who are trading various crypto assets on a variety of applications. And it's not an easy explanation, but you have traders looking to make money based on arbitrage and other opportunities using these decentralized blockchain exchanges. And in order to do it, they acquire Bitcoin or Ethereum as sort of a master currency. They loan that money out or use it to secure stakes in other currencies that they want to trade, and they convert it back. And all this happens on a 24/7 basis algorithmically. It is a really complex world. In the early part of 2020, as more of these algorithmic solutions got developed, people made a tremendous amount of money with it. And then the market tended to crash later in 2020. It's my thesis that most of the economic value is still accruing to Bitcoin and Ethereum, and not to these sort of DeFi types of coins. But I would say it's a fairly specialized part of the ecosystem for crypto assets, and one that is evolving very, very rapidly. And I wouldn't recommend dabbling in it unless you really sort of understand what's going on and what one is doing. But it became quite a bit of rage in this particular year of 2020. There was a concept that was developed called yield farming, where a bunch of really smart developers built these algorithms to move crypto assets around the world across exchanges and try to make money on these trades that they could then cash back out for Ethereum and Bitcoin, which have gone up greatly in value this year. So I don't know if that was the genesis of your question. That is one aspect of decentralized finance. The other aspect is that there are just exchanges where people are fractionalizing real estate and other things and trying to build fractionalized assets on a blockchain that they hope to attract smaller investors in.
Jeff, I think I got a question here from Wesley.
Yeah.
Hi, has the value of these Bitcoins, blockchain-based currencies, have they stabilized at all? How does the introduction of government-backed blockchain finance systems done to the values of other Bitcoins? By nature, I would think that Bitcoins can't really be backed by like gold or something. What's happened in this area?
Right. So they're not. So cryptocurrencies or crypto assets are simply backed by users' demand for it, right? I mean, that's what the value of a Bitcoin is, simply based on what you and I think the value of it is and are willing to pay for it. It is not, it is censorship resistant, it's tamper resistant, it has no governmental control or influence. And so one of the things that's driven the value of Bitcoin so high is that very few people own it. If you look at the $355 billion market cap, over 97% of all Bitcoins are owned by just 4% of wallet addresses. There's about 1 million Bitcoin wallets. 4% of them own 97% of those Bitcoins. They're typically very wealthy investors who are holding these, speculating that the value of them will rise. So they're essentially creating a scarce asset in the hopes that the price of it will rise. The question you asked that's really fascinating is, as central bank digital currencies come to the market, what will happen to these other kind of cryptocurrencies that are beyond government control? And the answer there is, I really wish I knew. There are some people in the United States who theorize that there are already countries that have banned ownership of Bitcoin, and that major governments, you know, their interest here is they don't ever want to lose control of their currency. And so as the value of crypto grows and Bitcoin grows into the $3, $4, $5 trillion worth of economic value range, and it is censorship resistant, meaning the government really doesn't know who owns it, whether people are paying taxes on it, whether it's being used for money laundering or other nefarious purposes. They will attempt to limit ownership of it and or regulate it in some way. Now, if that would happen, I would assume you would see the value of those things perhaps drop. But I don't think we know exactly how this is going to play out. I think what we do know is that digital currencies are highly efficient. Blockchains are highly secure. And there are lots of reasons a central bank may want to issue its own digital currency. But it's a very, very complex topic. Like today, you know, the United States government doesn't distribute currency. That's the job of the banking system. So if it would be that the US would issue FedCoin, and I would have a direct relationship to the Fed with a digital wallet, then the US government has to go in the business essentially of potentially disintermediating the banking system in order to achieve certain other benefits. So I think this is going to be one of the trickier things that economists are looking very hard at. I know, for example, you may have heard that a year ago, Facebook announced that they were going to introduce their own digital currency called the Libra. And they were going to distribute it through their social media platforms that have billions of users. And governments around the world threw up, you know, roadblocks almost immediately. I mean, Facebook's idea was to headquarter this in Zurich, Switzerland, beyond the control of the US government as a nonprofit over there. But I studied this at great length. There was tremendous concern on the part of major central banks that you could see these massive outflows of money from US dollars into Libra that could destabilize currency. And therefore, they put a lot of pressure on Facebook and its partners to not issue Libra in the form that it was. So even though Facebook had the technical abilities to build a better blockchain and overcome some of the limitations of Bitcoin, government said, we don't want you to do this. So my guess, I don't mean to give you a long-winded answer, is my guess is that somehow these cryptocurrencies are going to be limited in some way by governments.
These are going to be limited in some way by government. I think somebody's got their mic open and we're getting some feedback here.
Yeah. Sorry, Doug.
That's all right. So listen, I think we're going to wrap things up now. I wanted to tell you a little bit about the. All right, we're getting some feedback again. I'm going to mute everybody here.
Okay.
So anyway, we've got another presentation coming up on the 19th of January. That's 2021. This is going to be our last presentation of the year for IACT. Back in 2012, Becca Brown came and gave us a talk about her new product called Soulmates. And then she went on to, with her partner, went on to Shark Tank and raised a bunch of money. And now she's going to come back and tell us all about it. So I think that's very exciting. We'll have somebody from Shark Tank. And if you wouldn't mind unmuting yourselves now, let's give the speaker a hand. Thanks very much, Jeff. That was great. Thank you. Thank you, Jeff. All right, I hope everybody stays safe.
Jeff, you're muted.
Doug, I wanted to thank you again, and I'll send you these slides, and please feel free to share them with the group. And if anybody wants to contact me directly, my information is in there. I'm happy to discuss this further.
Terrific. Thanks a bunch, and enjoy your Thanksgiving weekend. Bye, everybody.
All right.
Bye-bye, everybody. Happy holiday.
All right.